Hello viewers, welcome back to my channel. In today's video, I will be talking about the SAS code which we can use to derive the treatment emergent flag in adverse event dataset for a parallel study. In this video, I will be talking about the parameters which will impact this derivation, but since this is more focused on the SAS code, I will be talking about these parameters from the SAS code point of view and its importance. If you want to know in details about the importance of these parameters, you can check my another video which I have created on the treatment emergent adverse event. Did I flag it right? A video in detail to know the importance of these parameters. So let's go to the SAS code which we can use. For this video, I will be using a dummy SGTM AE as well as the dummy ADSL dataset. So right now I'm creating my dummy SGTM dataset, which is the SGTM AE dataset having the data for 9 different subjects. In this AE dataset, I have kept only the variables which I will be using in my video for the treatment emergent flag derivation. Now talking about the parameters which we will have to consider while deriving the treatment emergent flag are, and first of all, the most important one is the washout period. A washout period in a clinical study is the period allowed for the administered drug to be eliminated from the body. Any AE that occurs during the period while traces of administered drug remains in the subject's body may be considered as treatment emergent adverse event. For this reason, a washout period in days is also added to the treatment end date in the algorithm for driving the treatment emergent adverse event. Different drugs have different washout period and hence should be carefully set after discussion with the investigators and statisticians. For this video, I will be taking the washout period of 7 days in this example. Now let's go through the ADSL dataset as well to understand more on how the washout period is implemented. So right now, again, I'm creating a dummy ADSL dataset and I have kept only the variables which I will be using in this video for my derivation. I have the subject ID and the treatment start date and treatment end date. So talking about the washout period, normally you will get to know more about the washout period consideration based on your how your SAP is built or what the SAP is mentioned, and the same can be seen in the logic for the derivation of treatment end date, which is the TRT EDT. In most of the cases in study SAP, it is mentioned that the washout period should already be considered while deriving the TRT EDT. And if that is the case for your study as well, then you do not specifically needs to add the washout period for your treatment emergent flag derivation because you have already considered that period when you have derived the TRT EDT variable. However, if in your study that is not been taken care and your SAP do mention that for the treatment emergent adverse event, you will have to consider the washout period of the study drug. In that case, based on the washout period mentioned in your SAP, accordingly, you will have to use that value in your derivation. So for this video, I'm considering that in the TRT EDT variables, I have not used the washout period for its derivation, but my study SAP do mention that I have to consider the washout period of 7 days to derive the treatment emergent flag. So how we can implement the washout period information in our code, we will see in few minutes. Now let's go back and see the SGTM dataset which we have created once again. So here, if you notice the second and third observation, This observation is for the same subject, that is the subject 1 or 2, and for the same adverse event as well. So this information is reflected in your A SPID ID. So here you can see that the SPID ID for both of these observations is same, which is as 002, mentioning that these two records belong to the same subject for the same A. Another point to note here for these two observations is that the second observation here, if you see that the start date for the moderate adverse event was the initial start date of this adverse event, and on 5th of October 2011, the severity of the ovarian cancer adverse event has changed to severe from moderate. So here, what is important to note here is that for a particular A, which was at the start categorized as of moderate severity, has changed to severe as the subject has progressed through the study. So in this study, you will see that what is happening is that the same adverse event, due to the change in severity, a different record for the same adverse event is being captured. And we are having two different records for the same AE, indicating the change in AE severity and the time where that is the start date and end date where the change in the severity is observed. Point to note here is that the severity has increased from the initial severity, which was at the start. So here the severity has increased from moderate to severe. Similarly, now if you will see the last two observation for the subject 109, here again for the dizziness AE, the severity has decreased from severe to mild, which means that when the subject has progressed through the study, at the initial stage, the subject has experienced a dizziness of severe severity, which has, as he progressed from the study, has been reduced or has, in other words, is improved to mild severity here. So how the change in severity, that is from whether the severity has worsened or has improved, will going to impact my treatment emergent flag derivation. The fourth point which we will be talking about in this video will be the scenario when your dates, that is the A start date or the A end dates, are partial date. So here right now I have a scenario for subject 105 who experienced a diarrhea adverse event where the partial date for the start date and end date was collected. So in this case, since the date is partial, how we will be comparing these dates with the complete date of your treatment start date to derive the adverse event treatment flag. So considering all these scenarios, let's see what SAS code we can write for this example. So first of all, what I will have to do is I have to prepare my SDTM AE dataset to ensure that all the partial dates are imputed properly. Since date imputation is only possible in Adam level, so you can say this is something which will not be done at the SDTM level, or the SDTM team will not be imputing the partial date. So as an Adam programmer, you will have to impute these dates at your level. So how we can do is as explained here. So now I'm reading the SDTM-A dataset which I have created just now, and I'm again creating the two variables, which is the uh, A end date or the A S start date here, which are the same as we have initially in our data, but we are going to modify its value to have the imputed dates. So to check whether these variables are having an imputed data or not, what we can do is we can apply a length function to these dates. So starting with the start date first. So if the length of the AESTDTC is 10, that means that this date is full, because if you will count the characters for a full date, you will note that two-digit value for the date, two-digit value for month, and four-digit value for the year comes out total as 8, with two hyphens in between date and month and year will constitute to total length of the complete date as 10. So using the length function on the variable like this, that length of a start date is equals to 10, if that is correct, then that means the a start date in this scenario is full date. So we do not need to do any imputation. We are just changing the format of the date in the correct format in which we want in the Adam data set. The next is that if the date length uh, is 7, when it will be 7, it will be 7 when the day part is missing. So if you will note again, the day part will, the two-digit values for day and one hyphen, in total 3. If that is not there, the remaining length of this date will be the 7 length, 4 for character, hyphen, and 2 for month. So if the length is equals to 7, then we need to impute only the day part. So we have already have the year and month for day part for the start date. Again, here again, SAP comes into picture. Normally, and in most of the cases, in SAP, it is mentioned that while imputing the start date, we will consider the first day of the month and first day and month of the year if the month is missing. So in this case, if such type of information is already given in your SAP, you can use that. It for day part, you are imputing the first of the month, that is 01 here. And similarly, when the only the year part is present in your date and you want to impute that date, you will have to impute day and month. And normally, again, in SAP, it is mentioned that the first January of that year is considered as the imputed part. So here, if the start date is having only the year part, then I will impute with -01, which will make the complete date as 1st January of that particular year. Now, this is the logic when the date is the start date. But if the date is your end date, then normally and in most of the cases, what we do is we consider the, for month part, again, we consider the uh, first of the month, but for the end, when the only the year is present, we consider the 31st December as the month and date part. So if your date needs to be imputed for only the day part, you can still use the 01 as the imputed day. But when you have to impute the complete date where only the year is given, then we will use the 31st of December as of that year as your end date, imputed date. So the same logic has been implemented here as well for the imputation of A end date. Right now, another check has been implemented here is that after the imputation, if by any chance the end date, the A end date is turns out to be greater, uh, less than the start date, then to rectify this issue, we are mentioning that if that is the case, then change the imputed end date to your uh, start date. That is, make the end date equals to your start date here. So having achieved this imputed thing, we will see what the data looks like after this. You will note that there was only one record where we were having the partial dates. We will see how the data looks like now. So here you can see the records where I was having the partial start and end date. Now, since for this record, the day was missing, but the month was March of 2014, the start date is being imputed as the 1st of March 2014. And similarly, the end date where only the year part was here, I have changed it to imputed date as 31st December 2014. So now I have the complete date which I can use for my derivation. So far, out of the four parameters which we have discussed, we have make sure that we have got the partial date parameters in place. Now I'm going to merge the just created adverse event data, which was AE underscore prepared with my ADSL dataset to get the treatment start and treatment end date from the ADSL dataset. Again, as I told that in this example, I am considering the scenario that my treatment end date does not take care of the washout period of 7 days. What I am doing here is that I am creating another variable, intermediate variable by the name of washout underscore end, and taking the treatment end date, I'm adding the 7 days period to that. The next step, what I am doing for the treatment emergent flag derivation. Again, please note that this is not the final derivation, but only the first part of the derivation where I am checking the washout period, impact of washout period on the treatment emergent flag derivation. So having derived the washout underscore end variable, which will be the 7 days more added to the treatment end date, I will apply this logic where I'm checking that when my start date is null as well as my treatment start date is not null, then for the scenario where my A start date is greater than equal to treatment start date and the A start date is less than the washout end date. So here, please note that I'm considering the washout end date because I want to make sure that the A start date falls in the period when the subject was exposed to the study drug. So if that is the case, then I am creating again an intermediate dummy treatment emergent flag variable by the name of TRTEMFL underscore DT, and I'm populating it as Y if the record satisfies this condition, that is that my A start date is greater than the TRT start date, but it is less than or equal to my washout end date. If that is the case, then the treatment flag is Y, else it is no. So in this, till this step, I have taken the washout period into consideration for the treatment flag derivation. So the resultant data set, in the resultant data set, you will see that the washout period is date variable is created, and I have also created the treatment emergent date underscore DT variable as well. So now moving on to the next and most important uh, condition is that is when this, what is the role of the severity changes in your derivation flag derivation. So here now the resultant data set, which is my A underscore merge, I am sorting it based on my use subject ID, SPID ID, and start date. Why I'm doing this is because I want to use that what was the initial severity of the adverse event, and using the initial severity, I will make sure that if the severity is getting worsened or improved, based on that, I have to derive my treatment emergent flag. So because of this reason, I'm sorting this data set, the intermediate data set, by this variables, which are the use subject ID, A SPID, and the A start date. And I'm using the same by statements here in my when I'm setting the A merge data set to create the A final data set. Here I'm using the retain function and I'm creating a variable by the name of previous severity, which will contain the value which is retained from the first severity value. And again, I'm using, I'm creating the A severity score variables, which is 1, 2, and 3, instead of using the mild, moderate, severe directly here. You can skip this part also in your code, but I found it more convenient to change the to use the severity score in the numeric format as compared to in your character format here. So having created the severity score with mild as 1, moderate as 2, and severe as 3, what I'm doing is that when I'm reading the data set, and if it is the first occurrence of the A sped, then I'm passing the value to my retained variable, that is the previous underscore severity, as the severity score. And I'm also capturing the value of my treatment emergent flag, which I have created in the above code, to my treatment emergent flag variable here. So in this part, what I have done is I have captured the, if for a particular adverse event, there are more than one record, then I have captured the first occurrence of the severity score value, and what was the flag which was derived based on the washout period logic. So now what I have to do is that for the scenarios where I had more than one record for the same adverse event, I have to compare the current record score value with my previous record score value. And if the current record score value is greater than the previous record score value, that means that for that particular A, the as the subject has progressed, the severity of that A has worsened. So in that case, I will mark the flag as Y. But if the severity has improved, that is, the severity score for the current record is less than the severity of the previous record, that means that when the subject is going through this study, the severity of the adverse event is improving. In that case, you cannot mark the treatment emergent flag for such scenarios as Y. For that scenario, you have to mark the treatment emergent flag as N. So that I have done in this logic. And in the last step, I'm keeping the treatment flag same as the treatment flag derived from the washout period for all those records where there were only one record per A. That is, there was only one severity records, and the severity was not changing for a particular A for a subject. So in this way, what I have achieved is I have created a treatment emergent flag taking into the consideration when there is a change in severity for a particular A, whether the change has been from uh, less to more or more to less, that is, in other words, whether the severity has worsened or improved. That particular logic has been implemented in this section of the code. Now let's go through the final A which we have just created. Now in this data set, if you will check the last subject, that is the 009 subject here, 109 subject here, you will see, as we have discussed earlier, that for this subject, the dizziness A had an improvement in severity. That was that it has improved from severe to mild. So if you will notice here, two variables, that was the treatment emergent flag underscore DT, which was having the flag value when it was only considering the washout period, and the other variable, which is the final treatment emergent flag, which is created after the after taking into consideration the washout as well as the change in severity. You will see that for the this subject, when there was a change in severity, that was the severity has improved, the treatment emergent flag for the improved record is populated as N, whereas it was populated as Y if you had only considered the washout period for the derivation. So in this example, you can see that the change in severities play a key role in identifying whether the improved severity record should be considered as the treatment emergent A or not. So that's all for today. In next future videos, I will also be talking about the SAS code, which we can use for the crossover studies and all the parameters to consider while driving the treatment emergent flag in our crossover studies as well. So that's all for today. Thanks for watching. Let me know in comments if you want me to cover any specific topic.